Your body is not just a body. It is a civilization, a world made of nearly 30 trillion living cells. Some carry oxygen through rivers of blood. Some build muscle, skin, and bone. Some send electrical signals that become memory, fear, dreams, and thought. Every second, parts of this world die, and every second, new parts are built. But the only reason the civilization survives is because almost every cell follows the rules. Cells divide when they are needed. They stop when they are told. And when they become too damaged, they destroy themselves. Not for themselves, for the survival of the whole body. But there is a weakness built into this system. To create new cells, old cells must copy their DNA, a genetic instruction manual, billions of letters long. Imagine a copy machine printing the same enormous book again and again for decades. Most copies are almost perfect, but eventually, tiny errors appear. A missing letter, a smudged word, a damaged page. Most mistakes change nothing. Some ruin the cell completely. But once in a while, one mistake changes the instructions in a dangerous way. A cell stops listening. It ignores the signals around it. It refuses to die. And instead of serving the civilization, it begins to live for itself. This is how cancer can begin. The human body is not a peaceful place. Every day, cells are damaged by sunlight, chemicals, viruses, and random mistakes hidden deep inside their DNA. Most of the time, the damage means nothing. Some cells repair themselves before the error spreads. Others detect the corruption and shut themselves down completely. And when a dangerous cell refuses to stop dividing, the immune system can destroy it before it becomes a threat. Specialized immune cells patrol the body constantly, inspecting millions of cells for abnormal behavior. They search for cells dividing too quickly, producing unusual proteins, or ignoring signals that normally keep tissue under control. In many cases, potentially cancerous cells are eliminated long before a tumor can form. But evolution does not need millions of successes. It only needs one survivor. Sometimes a damaged cell escapes detection long enough to mutate again. One mutation may allow it to grow faster than neighboring cells. Another may help it hide from the immune system. Another may disable the self-destruct mechanisms that protect the rest of the body. Over time, natural selection begins to take place inside living tissue itself. The most aggressive cells survive. The most adaptable continue dividing. A tumor is not just a mass of abnormal cells. It is a population evolving inside the body, shaped by the same forces that drive evolution everywhere else in nature. Even after escaping the immune system, cancer cells are still fragile. Most never survive long enough to become dangerous. But the ones that do begin changing in ways that make them increasingly difficult to stop. Cancer does not usually emerge overnight. In many cases, it can take years, sometimes decades. Long before a tumor is discovered, cells inside the body may already be competing, mutating, and adapting in silence. At first, these abnormal cells struggle to survive against healthy tissue and constant pressure from the body's defenses. But every new mutation is an opportunity, a chance to grow faster, to consume more resources, to spread into nearby tissue. And eventually, some cancer cells develop something even more dangerous: the ability to hide. Healthy cells constantly communicate with the immune system using chemical signals on their surface. Cancer cells can alter these signals, making themselves appear normal even when they are not. Some tumors manipulate the environment around them, recruiting blood vessels to bring them oxygen and nutrients. Others release chemicals that weaken nearby immune cells, turning parts of the body's own defense system against itself. By this stage, the disease is no longer just a group of damaged cells. It has become an ecosystem, a growing network of evolving cells, competing, adapting, and spreading through the body that created them. And yet, even now, cancer is surprisingly difficult to achieve. Because multicellular life has spent hundreds of millions of years evolving defenses against exactly this problem. It is easy to think of cancer as a modern disease, something caused by pollution, cigarettes, or modern lifestyles. And while many human behaviors can increase the risk, cancer itself is far older than humanity. Scientists have discovered evidence of tumors in ancient fossils, including bones from dinosaurs that lived tens of millions of years ago. long before the first cities were built, before humans existed, even before mammals became dominant on Earth, living organisms were already fighting the same invisible threat. Because cancer is not simply a disease. It is a consequence of complex life itself. The moment single cells began joining together to form larger organisms, a new problem appeared. How do you keep individual cells working for something larger than themselves? Every multicellular organism depends on an enormous level of coordination. Cells must divide at the right time, stop growing when necessary, share resources, and if they become too damaged, sacrifice themselves for the survival of the whole organism. Cancer begins when cells prioritize their own survival over the organism around them. In a strange way, multicellular life is built on trust. Countless cells following rules that allow the larger organism to survive. And for hundreds of millions of years, evolution has been trying to defend that fragile order from collapse, which may explain one of the strangest mysteries in biology. If cancer is an ancient risk for large complex organisms, then why are the largest animals on Earth not constantly destroyed by it? A blue whale contains far more cells than a human being. An elephant lives for decades in a body made of enormous amounts of living tissue. By pure probability, these animals should develop cancer constantly. More cells should mean more copying mistakes, more mutations, more opportunities for cancer to begin. But reality is far stranger. Many large animals do not experience dramatically higher cancer rates than humans. This mystery became known as Peto's paradox, and the answer reveals just how ancient this war really is. Over hundreds of millions of years, evolution has built different anti-cancer defenses into different species. Elephants, for example, carry extra copies of powerful tumor-suppressing genes. When their cells become damaged, they are far more likely to shut themselves down before the mutations spread. Some whales appear to have evolved extremely efficient DNA repair systems that reduce the number of dangerous mutations in the first place. And naked mole rats, small burrowing mammals that can live far longer than expected for their size, possess unusual biological mechanisms that make uncontrolled cell growth incredibly difficult. In other words, evolution never solved cancer completely. Instead, different species developed different ways to keep it under control. Cancer is what happens when cellular order begins to collapse. It is the cost of building something as large and complex as a living organism. And despite all the defenses life has evolved, the battle is never truly over. At first, curing cancer may sound simple. Find the dangerous cells, destroy them. But cancer creates a problem unlike almost any other disease. Because cancer cells are not foreign invaders entering the body from outside. They are your own cells, modified, mutated, reprogrammed by years of accumulated genetic mistakes. A virus can often be recognized as something foreign. Bacteria have structures the immune system can identify and attack, but cancer hides inside normal biology. Many cancer cells still carry the same surface markers as healthy tissue. They use the body's blood supply, consume the body's nutrients, and in some cases, even manipulate healthy cells around them into helping the tumor survive. This makes treatment extremely difficult. Fighting cancer is often like trying to remove criminals from a crowded city without damaging the city itself. Treatments such as chemotherapy and radiation can kill cancer cells, but they may also harm healthy, fast-growing cells in the process. Hair follicles, blood-producing cells, cells lining parts of the digestive system, and cancer continues evolving even during treatment. Inside a single tumor, different groups of cells may carry different mutations. Some die quickly, others survive. Resistant cells continue dividing, creating new generations that become harder to eliminate over time. In many ways, cancer behaves less like a single enemy and more like an ecosystem adapting to survive inside the human body. Which is why modern cancer research has increasingly shifted toward a different strategy, not simply destroying cancer directly, but helping the body's own defense systems recognize and fight it more effectively. Despite all its defenses, the human body was never designed to be indestructible. Over time, damage accumulates. DNA is copied again and again. Cells are exposed to sunlight, radiation, viruses, pollution, and chemicals carried through the air we breathe. Most of the time, the body's repair systems handle this damage remarkably well, but the probability of dangerous mutations slowly increases over the course of a lifetime. Some habits accelerate that process dramatically. Cigarette smoke, for example, exposes lung tissue to thousands of chemicals, many of which directly damage DNA. Ultraviolet radiation from sunlight can physically alter genetic material inside skin cells. Chronic lack of sleep, excessive alcohol consumption, obesity, and long-term inflammation can also place additional stress on systems responsible for repair and immune defense. None of this means cancer is completely preventable. Random mutations can still occur, even in healthy tissue, but risk is not fixed. Small changes repeated consistently over years can influence how much damage accumulates inside the body and how effectively the immune system responds to it. Some of the most powerful tools against cancer are surprisingly simple. Vaccines can prevent certain virus-related cancers before they begin. Early screenings can detect abnormal growth long before it becomes life-threatening. And habits like exercise, sleep, and avoiding smoking help the body's existing defense systems continue functioning effectively for longer periods of time. In other words, the goal is not to create a perfect body. It is to give this incredibly complex system the best possible chance to defend itself. Cancer is one of the most feared diseases in human history, and for good reason. It can grow silently for years, adapt to survive, and turn the body's own cells against it. But after everything we have explored, the most surprising fact may not be that cancer exists. The surprising fact is that complex life exists at all. Life exists because countless cells continue choosing cooperation over chaos, because damaged cells destroy themselves before threatening the organism around them. Because for billions of years, evolution has continued refining systems capable of holding this fragile balance together. Cancer is the risk that comes with turning individual cells into something vastly more complex. It is the price of becoming a living organism large enough to think, move, remember, and survive. And yet, for most of your life, your body continues winning this invisible war every single day. Long before humans existed, life on Earth was already fighting to preserve order against collapse. And somewhere inside you, at this very moment, that ancient battle is still being fought.